Hi, everybody. In this lesson, I'm going to go through parallel and perpendicular lines. So we are going to start by recalling our forms of linear equations. So we have three forms, and those three forms are slope-intercept form, and slope-intercept form is the form y equals mx plus b. And we're going to talk about what those things are in just a second. The next form is standard form. And standard form is the form ax plus by is equal to c. And then we have point slope form. Point slope form is the form y minus y1 is equal to m times x minus x1. All right, let's talk about the important pieces of each of these forms. We're going to start with slope-intercept. So slope-intercept is important because it tells us the slope, which is m. So m is our slope. And remember, this is our rise over our run. And your rise tells you how you are moving up and down, how your y values are changing, and your run tells you how you are moving left to right. You're going to go up if your rise is positive, and down if your rise is negative, excuse me. And then I always like to put the sign of my slope with the rise, so that way it's telling me go up or go down. And that way, if your run is positive, you're just going to run to the right. But if you do happen to have a negative run, you would be going to the left. I really like that. All right. Also important is our slope formula. It is really, if you have 2 points, x1, y1, and x2, y2, it is your difference in y values divided by your difference in x values. y2 minus y1 divided by x2 minus x1. So slope-intercept form tells us our slope. It also tells us the intercept of the graph. So this is our y-intercept, where we cross the y-axis. And the sign is included. This is a positive intercept if it's plus b. All right, standard form is kind of funky. You can find your x and y intercepts if you let y equal 0 and solve for x, then you'd find your x-intercept and vice versa for y. Really, the main things we need to know about standard form off the bat are that a, b, and c are usually integers. They can be a fraction or a decimal every once in a while, but normally they are just a positive or a negative whole number or 0. And if it's 0, then you don't really see the x or the y. All right, point slope form. Sorry. So there's this little thing that keeps popping up down here. Point slope form has the same m like we saw in slope intercept form. So this m is still our slope. The other important piece of this formula is the x1 and the y1. Those negatives are not included. You subtract your y1 from y and you subtract your x1 from x. So in this form, x1 comma, and let me fix that real quick. X1 comma y1 is a point on the line. All right. Let's now talk about parallel versus perpendicular slopes. So we're going to start with parallel. Parallel lines have the same slopes or equivalent slopes, equal slopes. They have the same slope. So if you know the slope of line N has a slope of A over B, then if I know this other line, maybe this is P, if it is also A over B, because these two slopes are the same, N is parallel to P. They are parallel lines because their slopes AB is equal to AB. And I'm being kind of abstract here. Their rise and their run is the same between any 2 points. Perpendicular lines have negative reciprocal slopes. This negative reciprocal is kind of like also known as an opposite reciprocal. And the reciprocal of a number, if you take that number and you multiply it by its reciprocal, it will equal 1. So, for example, just a quick example, 1 over 2 times its reciprocal, 2 over 1, you just flip them, that is 1. So your negative reciprocal if you have some slope, some fraction A over B, your negative reciprocal would flip your numerator and denominator, and it'd be negative. And when you multiply across the top, should have done it like this, when you multiply across the top and across the bottom, A times negative B is negative AB, and B times A is also AB. So this is just negative 1. They really just cancel each other out and you're left with negative 1. So your negative reciprocal multiplies to negative 1. I like to think of it as if you have perhaps your slope of line L is 1/2, and we have this perpendicular line, and this is slope of a number, not you, we'll do J here. You would take your 1/2 and you would flip your numerator and denominator, and you would make it negative. So it'd be negative 2 over 1, and this would be perpendicular. So L would be perpendicular to J. All right, let's look at some examples. This is not going to be our first example. These are coming in later. Let's just move these down for a second. All right. Number 1, determine if the lines negative 2y equals negative 8x plus 7 and y equals 4x minus 1 are parallel, perpendicular, or neither? So to determine this, we have to look at their slopes. We need to find the slopes of both lines. So I'm just gonna start with line 1, which is negative 2y is equal to negative 8x plus 7. And this kind of looks like slope-intercept form, but it has this negative 2 being multiplied to the y. So I need to actually solve for y here, and I need to divide both sides of this equation by this negative 2 to figure out what this equation slope is in simplified form, because this equation's been multiplied by 2, or sorry, negative 2. So I'm going to divide both sides by negative 2, so they will cancel in the numerator and denominator here on the left, and we have y is equal to, and then I really just have negative 8x divided by negative 2 plus 7 divided by negative 2. And this will simplify even further. Y is negative 8x divided by negative 2 is just 4x. And then plus 7 divided by negative 2 is just negative 7 over 2. So minus 7 over 2. So line 1, the slope here, the number being multiplied to x, remember this is like our y equals mx plus b. So our slope is 4. The number being multiplied to x is 4. Line 2 is a little bit more straightforward. Line 2 has the equation y equals 4x minus 1. And this is also in the form y equals mx plus b. So we can find that slope, that m, it is also 4. So this also has a slope of 4. So because these slopes are equal, same slopes. So these lines are parallel. All right. Now we're going to use these graphs. So these are in your lesson notes images for this lesson. So please, if you can print them out, do so. Otherwise, you can easily recreate this graph with just a ruler and a pencil. So we are going to start by graphing a line parallel to the given line. I'm going to kind of make this a little bit bigger and move this one out of the way for right now. So if it is parallel, it's going to have the same slope. Parallel means it will have the same slope. So if we have this line here, let's call this line L, let's find the slope of that line. So I am going to find the rise over run between any 2 points on my graph. So I see this is a good point on my line, and that doesn't show up very well. This is a good point on my line, and this is a good point on my line. So I'm going to find the slope. I would have to start with my rise, please. Let's start with your rise, please. And we would have to rise up 1 unit. Oh, what in the world? Rise 1. And then we would have to run 1, 2, 3. So our rise is positive 1 because we went up, and our run is positive 3 because we went to the right, which is great because I started at the left-hand side. Oops, I don't know why I did that. So all in all, this slope is 1/3. So a parallel line should also have a slope of 1/3. So I am going to really just graph another line with a different y-intercept. So I'm going to do positive 2, and I will use my same slope. I'll go up 1, rise 1, and I will run over 1, 2, 3. And this will be my new point, which I can connect to those 2 of those dots with a line. You only need 2 points to graph a line. So that line would be parallel. Now let's graph a perpendicular line. Oops, 3. Graph a line perpendicular to the given line. All right. So here's the same, it's the same graph. So this is still the same slope. We don't have to recalculate it. So this will be line L, and it has a slope of 1/3. So a perpendicular slope is a negative reciprocal slope, which means I'm going to flip my numbers. So this slope would be 3 over 1, and then I would make it negative. So flip it, make it negative. If it's already negative, then those 2 negatives turn into a positive. So this perpendicular line, remember that's our symbol for perpendiculars, perpendicular line has a slope of -3 over 1. And that's really the same thing as just -3 simplified, but this is helpful to us. If it's -3 over 1, that means we will rise -3 units and run 1 unit. Notice I put the negative with the 3. That tells us we're going to go down 3 units, and then we'll just run over that 1. So my y-intercept can be anywhere. So I'm going to plot my y-intercept. Let's see, I'm going to do it 2 again. Why not? And I'm going to rise down since it's negative 1, 2, 3 units. And then I will go to the right 1. If I went to the left, it would become a positive slope because I would have 2 negatives. So now I have 2 points plotted, my y-intercept and the new point using the slope, which can be connected with a line, kind of. And let's see, I'm gonna rotate it just a little bit. And there would be our perpendicular line. So using that negative reciprocal slope. Number 4. What is the equation? You know what? I'm gonna skip that one. What is the equation of the line that passes through -5, 3? So it passes through this point and is perpendicular to the line x plus y is equal to 2. So if you have this equation, right? So this is our original equation, and this is note in standard form. I need to convert this to slope-intercept, which means I'm really just going to solve for y. Try to get y all by itself. So x plus y is equal to 2. I need to solve for y so that I can find the slope, right? We need that slope to be able to write a perpendicular line. So I'm going to solve for y here. This equation is pretty straightforward. I really just need to move this x term over. I don't know what I'm doing. I'm going to move this x term over, and it's positive right now, so I will subtract x from both sides of my equation. The x's will cancel. We'll be left with y is equal to 2 minus x. And really, this is also the same thing. I can flip that. This is y is equal to -x plus 2. So looking at this equation now, I can find the slope, and the slope's kind of hidden, but it's actually this -1 attached to the x. So our slope is -1. So if I'm going to have this perpendicular equation, a perpendicular slope to -1, this is like -1/1, I would take our -1/1, and I would flip my numerator and denominator. So it would still just be 1/1, but now I would also make it negative. So it would be a negative slope, which is positive. So a perpendicular slope to -1 would be just 1, and it'd be positive. Now I can write my equation. We have this point. So let's talk about this point. We have this point on the line, -5, 3. So this is like an x1, and this is like a y1, and I can write my equation in point slope form. So let's use point slope form. So that is the y minus y1 is equal to m times x minus x1, just using my notes from up above. And we know all of these things, right? We know that our x1 is -5, our y1 is 3, and then that perpendicular slope, m, is +1. So now I can substitute in all of my values. I will have y minus that y1 value, which is 3. And I'm going to substitute my values into parentheses. And that is equal to our slope, which is 1. Since that's on the outside by itself, I'm going to just leave that. 1 times x minus our x1, and our x1 is -5. So now I can simplify y minus 3, just getting rid of the parentheses, is equal to 1 times x plus 5. And I don't really need that 1 there. So I can clean it up even more. We have y minus 3 is equal to just, if you distribute the 1 to both the x and to the +5, we would just have x plus 5. And now I can really rearrange this into an equation that looks a little bit more familiar to us if I simply move this -3 to the other side by adding 3 to both sides of the equation. So we will get y, let's cancel, equal to x plus 8. So this would be a perpendicular line to our original equation. And it passes through that point, -5, 3. Please let me know what questions you have, and I look forward to seeing you in class.